Welcome to Tech Unplugged. Today we're diving deep into the security around something called the Model Context Protocol, MCP for short.
Right.
Think of it as like a way for AI assistants to connect to different tools, different data sources, makes them way more powerful.
Absolutely. It's the plumbing, in a way.
Exactly. And this deep dive is really for you, the learner, who wants to get the important stuff quickly, thoroughly, without getting lost in all the heavy jargon.
Mm-hmm.
We'll unpack what MCP actually is and, crucially, the potential security worries that have started popping up recently.
Yeah, and they're pretty significant.
Our mission here is to pull out those key nuggets, highlight the surprising bits, and really help you understand what this all means for, well, the future of how we interact with AI.
And it's developing fast. I mean, the speed MCP is being adopted is...
Well, it's quite something. You're seeing it used already.
Oh, yeah. Workflow automation services, they're already processing like millions of requests using MCP endpoints.
Millions. Wow.
Yeah, that kind of rapid growth really tells you something about its potential. It could become, fundamental to AI ecosystems, enabling much more complex stuff.
Absolutely. And it's that speed, that integration, that makes understanding the security side so important right now.
Couldn't agree more.
So one of the big ones that's emerged is this thing called tool poisoning attacks. Okay, let's get into this. What exactly is a tool poisoning attack in the MCP world?
Well, what's really clever or maybe insidious about it is how it exploits the tool descriptions themselves.
The descriptions, how the tool is explained.
Exactly. So tool poisoning basically involves hiding malicious instructions inside that text description. Instructions the user never sees.
Hidden how?
Well, they're crafted so they're invisible in the normal user interface, the simplified view you get. But the AI model, it sees them. And worse, it can execute them.
Okay, hold on. So it's like hiding secret orders in plain sight, but only the AI can read the secret part. That sounds tricky.
It is. Super insidious.
Can you give us an example? Like, how would that actually play out?
Sure. Imagine a really simple tool, one that just says it'll add 2 numbers. Seems harmless, right?
Yeah, basic math.
But a bad actor could inject hidden instructions into that tool's description. Maybe instructions telling the AI to, say, find and read sensitive files, like your SSH keys or maybe config files, and then secretly send that data off to the attacker's server. So while you think you're just asking the AI to calculate 2 plus 2...
It's actually grabbing my private keys in the background.
Potentially, yes.
Cool.
Your AI assistant is moonlighting as a data thief, basically, without you having a clue.
And this works because...
No.
Well, because MCP originally just assumed those descriptions were safe, that they could be trusted.
That's the core issue, yeah. The initial security model kind of operates on this assumption of trust, that the descriptions are honest.
Which is proving not to be the case.
Exactly. It didn't really anticipate that the descriptions themselves could be the attack vector. It's a bit sobering, isn't it, that this foundational trust is already being exploited.
It really is.
Yeah.
Have people actually shown this works?
Oh, yes. There have been experiments, demonstrations using actual AI coding agents. They managed to inject a poisoned ad tool, just like the example, and successfully got the AI to leak sensitive files. Things like the mcp.json file, which might contain credentials for other MCP servers.
Oh, that's bad.
And even SSH keys used for secure logins.
And the user is none the wiser because the interface just shows add tool or something simple, hiding the malicious details buried in the full description.
Precisely. That lack of visibility is a huge part of the problem. You see the simplified version, and there's no easy way to inspect the full, potentially dangerous instructions the AI is actually working with.
Okay, so tool poisoning is one major issue. But it sounds like that's not the only trick up attackers' sleeves. There's also something called the rug pull. That name alone sounds bad.
It does, doesn't it? And it is quite concerning.
This changes things, right? It's not just about checking something once when you install it.
Exactly. The rug pull exploits the MCP server architecture. These servers host collections or packages of tools.
Right.
So a malicious server could initially offer tools that look perfectly fine. You check them out, you approve them, you connect, all good.
Yeah.
But the server operator can potentially change the tool description after you've already installed and approved it.
Wait, really? So they bait and switch, you approve the safe version, and later they swap in something nasty.
That's the danger. It's a good analogy. Even if you did your due diligence initially, the server could later modify that tool to include harmful code. Maybe silently. It's quite similar to risks we've seen with, like, software package managers, where a compromised update gets pushed out.
Okay, that makes sense. And this gets even messier, I imagine, because AI agents often connect to multiple MCP servers at once, right?
Yes, absolutely. That's a very common setup. Users want access to lots of different tools from different places.
Which leads to another problem, something about cross-server tool shadowing,
Indeed. This is where it can get really tangled. When your AI agent is talking to several MCP servers simultaneously,
which is normal.
right, a malicious server can essentially shadow or override tools provided by a legitimate, trusted server you're also connected to.
Okay, run that by me again. It overrides a good tool with a bad one.
Sort of. Imagine you have a trusted server offering, say, a reliable email sending tool.
Got it.
Now, a different malicious server you're also connected to could offer a fake tool. Maybe it calls itself addition again, something innocuous. But hidden in the description of that fake addition tool are instructions that interfere with the real email tool.
Yeah.
They might tell the AI that anytime it's asked to send an email, it should actually send it to the attacker's address instead. Or maybe BCC the attacker on everything.
Oh, wow. So even if I explicitly tell the AI, use the trusted email tool to send this, the instructions from the fake math tool hijack it.
Exactly. The AI agent effectively merges all the tool descriptions from all connected servers into one big context.
So it gets confused, or rather manipulated.
Manipulated is the right word. It becomes very hard, maybe impossible, for the AI to tell which instruction came from where or which one to prioritize if they conflict, especially if the malicious one is designed to override.
And I bet this doesn't show up nicely in the logs either.
You guessed it. These shadowing attacks often leave no trace in the logs you'd normally see. The interaction might look like it's happening with the trusted tool, but behind the scenes, the rogue instructions are doing the damage. Makes detection incredibly difficult.
Okay, so we've got tool poisoning, rug pulls, cross-server shadowing. These are all sort of inherent to how MCP works with tools and servers. What about more like traditional security holes? Are they still a problem here?
That's a really important question, and the answer is yes. Adopting MCP doesn't magically fix old security problems. We're seeing familiar threats pop up in this new context, too.
Such as,
Well, for starters, plain old unsafe code in the MCP server implementations themselves, things like command injection or remote code execution RCE.
so attackers could just take over the server.
Potentially, yes. Some research found that a surprisingly high percentage, something like over 40% of tested MCP servers had unsafe shell calls. That's a direct line for an attacker to potentially run their own code on the server if they can exploit it.
Yikes. Okay, what else?
Another big one is token theft, leading to account takeover. MCP servers often need to store authentication tokens, the keys that let them access other services on your behalf, like your email or cloud storage.
Right, so they can actually do things.
Exactly. Now, if an attacker compromises that MCP server,
They get the keys.
they get the keys, they can steal those tokens and then impersonate you on all those connected services. And because it looks like legitimate activity coming from the authorized MCT server, it might not trigger the usual security alerts.
Oof. And I guess the permissions these servers ask for don't help. I imagine they often ask for broad access to be useful.
That's another amplifier, absolutely. To be flexible, MCP servers often request really wide-ranging permissions, access to email, files, calendar, you name it.
So it concentrates a lot of power in one place.
Precisely. It becomes a very attractive target. Compromise that one server, and you potentially get the keys to the kingdom, access to a vast amount of the user's sensitive data and capabilities all at once.
And this all comes back, again, to the user not really seeing what's going on under the hood, right?
It really does. That lack of visibility is a recurring theme. You don't see the full internal prompts, the detailed tool instructions the AI is processing.
Which lets these attacks hide in plain sight.
Exactly. Tool poisoning, shadowing, even the results of a token theft, they can all happen without the user interface showing anything unusual. It creates a fertile ground for these hidden attacks.
Okay, this is painting a bit of a grim picture. But surely people are working on fixing this. Are there ways to mitigate these risks, to build a safer MCP world?
Yes, absolutely. Thankfully, awareness is growing, and there are definitely promising strategies being developed. One of the most interesting avenues is using trusted execution environments, or TEEs.
TEEs, what are those?
Think of them as like a secure vault, a protected area within a computer's processor. Code and data inside a TEE are isolated from the rest of the system, even from the main operating system, or a privileged administrator.
Okay, a secure little black box for code. How does that help MCP?
Several ways. First, You can harden the MCP servers themselves by running them inside a T.
How does that help?
Well, it shields the server from compromises on the host system. Even if someone hacks the main server OS, they can't just reach into the T's memory and steal things like those sensitive OAuth tokens we talked about.
Ah, okay. Protection from outside interference.
Right, and there's more. T's support something called cryptographic attestation.
Attestation.
Yeah, it's like getting a digital certificate that proves exactly what code is running inside the TE and that it hasn't been tampered with.
So you can verify the server is running the code it claims to be running.
Precisely. Which
Yeah.
is a direct countermeasure against those rug pulls, right?
Right.
You can verify you're connecting to a server running the expected untampered tool logic.
Gotcha. So it's like a tamper-proof seal on the server software.
That's a great way to put it. And we're already seeing platforms emerge that offer this kind of T-backed MCP hosting with attestation built in. So your AI agent can actually verify the server's integrity before it even starts using its tools.
That sounds like a pretty solid step towards building trust.
It's a much stronger foundation, definitely.
Are there other ways T's can help secure MCP
Oh, yeah.
beyond just the server?
No, yeah. You could potentially build attestation or digital signatures right into the MCP protocol itself.
So when the agent connects.
It demands proof. It verifies the server and maybe even the specific tools it's about to use. This moves towards a zero-trust model, don't trust, verify.
Okay. And could that help with the shadowing problem too?
It could, potentially. If each server's contribution to the context is somehow signed or attested, the client agent might be better able to differentiate or prioritize instructions, or at least detect tampering.
Makes sense.
Hmm.
What about the data itself? Can T's protect the sensitive information being processed?
Yes, that's another key benefit. Since T's provide confidentiality, they can protect data while it's being processed.
How so?
Say an MCP server needs to analyze a confidential document for you. It could do that work inside the T, meaning the document itself is never exposed in plain text to the potentially insecure host system or network.
So the data stays encrypted or protected even when it's being used.
Exactly. Even the AI model's queries and the tool responses could potentially be encrypted end-to-end between the client and the server's T. Plus, the T can enforce very specific rules, fine-grained policies about how data is accessed, which can also limit the damage from things like prompt injection attacks.
Okay, T's sound really powerful here. A strong base for building more secure MCP.
They offer a lot of promise, for sure. And you can even extend the idea. In really high security situations, maybe the AI agent itself runs inside a T on the user's machine.
A T guarding the agent.
Yeah, acting as a mediator and enforcing security policies on the agent's actions. It's like defense in depth. Layers of security. Oh, and one more thing. T's can produce tamper-evident audit logs. Logs that you can trust haven't been messed with, showing exactly what actions the agent performed. Great for accountability and figuring out what happened if something does go wrong.
Okay, so T's aren't a magic bullet, but they tackle a lot of the core issues. Trust, confidentiality, integrity, auditing.
Pretty much, yeah, they provide strong building blocks.
And this must be opening up ideas for new security products, right? Services built around securing this MCP ecosystem.
Absolutely. The current vulnerabilities definitely create opportunities for innovation. You can imagine several things emerging.
Like what?
Well, obviously, trusted MCP server hosting platforms, services that make it easy for people to deploy their MCP servers inside TEs with all the attestation stuff handled.
Okay, secure hosting. Makes sense.
And then you could have something like an MCP security broker or firewall, a separate service that sits between your AI agent and the MCP servers it talks to.
A gatekeeper.
Exactly. It could inspect tool descriptions, sanitize them, enforce security policies, look for suspicious patterns, maybe block connections to known bad servers.
Interesting. What else?
For businesses, maybe confidential AI sandboxes, secure TE-powered environments where they can run AI agents and MCP tools on their sensitive corporate data with strong security guarantees and monitoring.
Right, for enterprise use.
And developer tools are key too, SDKs, libraries that help developers build secure MCP integrations from the start, things like input validation, maybe ways to run tools in restricted modes, plus tools to actually test the security of MCP servers. Those are starting to appear too.
Like scanners for vulnerabilities.
Yeah, along those lines. And finally, pushing for stronger standards within the MCP protocol itself. Things like requiring signed tool manifests or encrypting the sessions by default. That foundational work is critical.
So it really needs a multi-layered approach. Tech like TEs, New security tools, better standards, safer development practices.
That's right. It's not one single fix. And until those robust measures are common, are widely adopted across the board, protocol, server, client users really need to be careful.
So, practical advice for right now.
Extreme caution, especially with third-party MCP servers you don't fully trust. Maybe disable any auto-run features they might have. Definitely try to verify who runs the server and if they're trustworthy before you connect your agent to it.
Due diligence is key.
And keep an eye out for tools that aim to help with this. You mentioned scanners. There are efforts, like one called MCP Shield conceptually, aimed at analyzing tool instructions to spot malicious patterns. That kind of tooling will be important.
Okay, let's try and wrap this up. Let's unpack what this all really means. MCP, the Model Context Protocol, it's clearly a big step. Makes AI agents much more capable by connecting them to all sorts of tools.
Huge potential, yeah.
But, as we've spent this whole time discussing, this new power comes with some pretty serious security baggage that we just can't ignore.
Definitely. And I think what's really interesting, maybe the core takeaway, is how vulnerabilities like tool poisoning and cross-server shadowing just hammer home the need for a zero-trust mindset in these AI systems.
I mean,
Meaning you just can't assume a connection or a tool description is safe just because it's there. You have to assume risk. You have to verify. That default trust model, it's broken.
so what does this mean for you listening? Well, as AI gets woven deeper into everything we do, understanding these underlying texts like MCP and, crucially, their weaknesses, that becomes really important. The good news is that work is happening. Things like T's, new security tools, efforts to scan for bad behavior, these are vital steps towards building an AI future that's not just powerful, but also safer.
It's an ongoing process.
Absolutely. Thank you for taking this deep dive with us into MCP security. It's moving fast, this whole area, so we really hope you stay curious, keep digging, keep asking the tough questions.
Thank you for listening to Tech Unplugged. Stay tuned for more in-depth explorations of the technologies shaping our world.